And if it can't empty as fully, it's going to be bigger, right? So if you keep your eye on that left ventricular end diastolic volume, it's not going to stay at 118 once I tighten the aortic valve. So why don't we just go ahead and do that? And I'm going to make the valve initially just a bit tighter. But it's going to have an obvious effect. Look what's happened now to those two pressures. Now the left ventricular pressure, the red line, goes much higher than the aortic pressure, because now there is resistance that makes those two pressures different. The aortic pressure doesn't rise as fast or as far as it did before. And I don't know if you were paying attention to the left ventricular end diastolic volume that started at 118, but notice that the heart's already fuller. It's already suffering the impact of this tighter valve. If you like, you can test more subtle effects on the valve by tightening it less, or more dramatically in ways that will really cause the heart to have trouble. So now I've created a loop that is the cardiac pressure volume loop. And as I click on that, you'll notice that it's not just sitting there. Let me just make this bigger so we can focus on this for a moment. This is actually the cardiac cycle of the heart filling during diastole, then contracting in what's called isovolumic contraction. Then the volume starts to decline as the valve opens. So this is another way of looking at the aortic valve opening, the heart ejecting, and then the aortic valve closing, isovolumic relaxation. This is the left ventricular pressure volume loop. And that loop, the area of that loop, is related to the work that the heart is doing. Think of what's going to happen to the whole heart volume as I tighten the valve. And of course, the blood pressure goes up. You see that the left ventricular pressure goes up. You see that here, and you see it here. And notice that with each beat of the heart is filling a little bit more, a little bit more, a little bit more, as that whole loop shifts up as the heart fills. Fills more because it can't empty, because the valve is tightened. Okay, so I'm going to go through one more simulation here, and the purpose of this simulation is to demonstrate the interconnectedness of different systems, something which is really hard to do in a textbook or a lecture and really easy to do with simulation. So I'm going to shift to the respiratory system for a bit, and so I'm going to draw your attention now to these pressures as a function of time. I'm going to show you in the black line the airway pressure. That just means the pressure at my mouth right now. The red line, which is the alveolar pressure, the pressure in my alveoli in the lung. And the blue lower pressure is the pleural pressure, the pressure in my pleural space. And to illustrate how those are different and why they're different, I'm going to put this patient on a mechanical ventilator. And he is now on a breathing machine. And now if we look at the airway pressure, notice that with every breath that black line is going up. That's because now the ventilator is working as a pump to create pressure to push air into me, and only then does my alveolar pressure, the red line, begin to rise. And because I'm not exerting any effort anymore, my pleural pressure, the pressure in my pleural space, rises as the lungs are made bigger and push on the chest wall. Back to interconnectedness, you predicted what was going to happen to the heart, right? If we fill up the lungs more than they're usually filled, it's going to squeeze the heart. The heart's going to get smaller, isn't it? And you saw it happen. The left ventricular end diastolic volume fell, and the blood pressure fell. The heart and lungs affect each other in ways which are inextricably tied to each other, and ways which in the real life of medicine are important. And what I'm going to do now is I'm going to create some asthma. I'm going to tighten the airways. and I'm going to make it harder to get air in and out of these lungs. And you should think about what that's going to do to the pressure that the ventilator has to generate to push air into these lungs. So as I create asthma, you can already see the pressure here is now having to rise higher. You see that? It was this low, now it's higher. There are other more subtle things happening too. But look at the shape of that when I go back to no asthma. By the shape of that, what I mean is look how quickly the alveolar pressure falls back to the baseline value of the airway pressure. In other words, the lung empties pretty quickly. But watch again as I create asthma. The alveoli empty more slowly, more gradually. Their emptying is impaired. You see that? In fact, the alveolar pressure at the end of the breath is still a little bit higher than the pressure at my mouth or the pressure here in the breathing tube. Not recognizing the physiology and not understanding this interaction between respiratory and cardiovascular systems. With my breathing machine, I'm going to squeeze the heart smaller and smaller and smaller. And as I look at that, and if I were to display the heart rate, with the blood pressure falling, you know what's happening to the heart rate, right? This patient is starting to scream. This patient is headed towards death. And if we don't recognize the physiology, if we don't undo something of what we're doing, the heart's going to get smaller and smaller. It'll beat faster and faster. But I start to sweat because it looks like he's going to die. And ultimately, of course, when he gets sick enough, a message will pop up and say, he's dead. So I'm now going to show you that within SimBioSys is a physiology textbook. So if I click up here on textbook, I can open this to chapters on membrane physiology, for example, covering membrane structure or diffusion. For example, in this chapter on membrane permeability, there's one of many animations that you can play through that illustrate the concepts that are described in the text material. So for example, here's an animation showing a lipid membrane with extracellular fluid on the left and intracellular fluid on the right. And this has a voiceover that I'm not playing right now, but that will explain what's happening in the animation to use that as additional teaching material. And there are many animations like this throughout SimBioSys. If you look in this tree on the left, you'll notice that in addition to these text chapters, that there also are quizzes. So we can go to a quiz that will ask questions related to the text material, which you can answer. And there are also exercises. So if I open an exercise, for example, I can pull up now the same kinds of displays that I showed you in the viewers before, but now they're pulled into exercises which will more guide you through so that you can do your on-your-own learning.
Okay, quick question with the quizzing feature. Does it grade as I go along and answer the questions? Will it tell me what I've done wrong and what I need to go back to look at?
Yes, it will grade you, it will help you learn, tell you what you need to go back to and read again. Finally, there is help about how to use the program so that as you're navigating, you have the ability to learn how to better use the viewers, how to customize them, how to illustrate what you want to see or demonstrate what you want to show. I can teach this at all kinds of levels too. That's another one of the nice things about simulation.